Welcome back. Now that we've defined the cloud models, it is critical to know when to apply them. In this session, we will identify the specific business scenarios and technical requirements that drive the selection of public, private, and hybrid cloud models. To identify the appropriate use case, we must first understand that cloud deployment models public, private, and hybrid dictate the physical location and management of your resources. Your choice isn't just about technology, it's about business constraints. We evaluate this based on budget, specifically the shift from capital expenditure to operational expenditure, security requirements, the need for scalability, and how much maintenance your team can handle. In this video, we will map these factors to real-world scenarios to ensure you select the right environment for your workload. This mind map visualizes the decision matrix we use. At the center is cloud selection factors. Branching out, we see budget, where we weigh CapEx against OpEx. Next is security, driven by compliance and sovereignty needs. Scalability looks at the need for bursting or global reach. Finally, maintenance asks if you want to manage hardware and patching yourself or offload it. These four nodes guide us to the correct use case. When should you use the public cloud? First, it is the best fit for unpredictable traffic. Because the public cloud allows you to pay only for what you use, you can handle massive spikes in demand without paying for idle servers during quiet periods. Second, it is ideal for startups and development environments. It supports a scale fast, fail fast model where you can spin up resources in minutes to test an idea without buying hardware. Finally, it is the home of SaaS and public web hosting, where the provider manages the underlying infrastructure so you can focus on the application. This diagram flows from left to right, showing the inputs for public cloud. We see a startup needing prototyping and a retail web app experiencing traffic spikes. Both feed into the public cloud node. From there, the system outputs auto-scale capabilities, leading to on-demand resources, and an OpEx model, resulting in pay-per-use billing. This visualizes the conversion of variable demand into cost efficiency. In contrast, the private cloud is the appropriate use case when control is paramount. This model consists of computing resources used exclusively by one business. It is often required for regulated industries like healthcare or finance, where strict compliance mandates dictate exactly where and how data is stored. Furthermore, if you have legacy applications that require specific hardware configurations or older operating systems that public providers don't support, the private cloud allows you to customize the environment to those exact specifications. You retain full responsibility, but gain total control. The hybrid cloud enables you to combine the best of both worlds. A primary use case is data sovereignty. You might host a web application in the public cloud for global reach, but keep the sensitive customer database in your private data center to meet legal residency requirements. It is also the ideal model for gradual migration. Instead of moving everything at once, you can move front-end services to Azure while keeping legacy back-end systems on premises, connecting them via a secure tunnel. This flexibility allows you to optimize your infrastructure for both compliance and innovation. This sequence diagram shows a classic hybrid workflow. The user interacts with the public cloud web app, leveraging the cloud's global scale. However, when data is needed, the app sends a request over a secure VPN to the private on-prem DB. The sensitive data is retrieved securely and sent back. This demonstrates how hybrid cloud splits the workload, public for access, private for security. A specific and powerful hybrid use case is cloud bursting. Imagine you are a retailer. Most of the year, your private data center handles the load. However, during Black Friday, demand spikes. Rather than buying servers that sit idle for 11 months, you configure your system to burst into the public cloud. When your on-premises capacity hits 100%, overflow traffic is automatically routed to the public cloud. You pay for those extra resources only during the spike, eliminating the need to over-provision your own hardware. This state diagram visualizes the logic of cloud bursting. The system starts in on-prem operations. It constantly performs a check load. If load is under 100%, it stays on-prem. If load exceeds 100%, it transitions to cloud burst, utilizing public cloud resources. Once the load decreases, the loop returns to the base state, visualizing the elasticity of the hybrid model. Finally, we must identify the multi-cloud use case. This involves using multiple public cloud providers simultaneously, such as Azure and AWS. Organizations choose this to avoid vendor lock-in, ensuring they aren't dependent on a single company's pricing or availability. It also allows for a best-of-breed approach. You might use Azure for its superior Active Directory and Office 365 integration, while using another cloud for a specific legacy compute requirement. This strategy maximizes flexibility and leverage in negotiations. This graph illustrates a multi-cloud architecture. The central enterprise application connects to 3 different nodes. It uses Azure AD for identity, AWS EC2 for compute, and Google BigQuery for analytics. This visualizes the best-of-breed concept, where the application is composed of the strongest services from each provider, rather than being locked into one. To summarize, identifying the appropriate cloud model comes down to your specific constraints. Choose the public cloud if your priority is scaling and reducing upfront costs. Choose the private cloud if you require absolute control and security compliance. Choose hybrid or multi-cloud if you need the flexibility to bridge these worlds, handle temporary surges via bursting, or leverage the best features from different vendors. Understanding these distinctions ensures your architecture aligns with your business goals.